Hello, good evening.
Good evening, sir.
Good evening, sir.
Do you have any doubt from last class to any one of you in Bernoulli's principle?
No, sir, it's clear.
Okay. I will take your Viva at the end of the class, okay?
Yes, sir.
Okay. So in last class, we had just derived Bernoulli's principle on the basis of which I defined the Magnus effect. Next is taking off of aeroplane or upliftment of aeroplane. Suppose there is a plane which is moving along this direction at some velocity, due to which air coming from front side may move like this way, and from bottom, on hitting this bottom surface, they will get stopped. So at the bottom part, velocity will get decreased, but top surface velocity will get increased. Due to this change in velocity between these two different portions of plane, pressure will consequently changes. According to Bernoulli's principle, we can write pressure plus half rho v square plus rho gh is equals to constant. So if velocity is decreasing, pressure must be increasing, so that the sum of these terms at that instant should be constant. So at the upper end, velocity is increasing, so pressure must be decreasing. Similarly, at the bottom end, due to decrease in its velocity, pressure will get increased. Now, this pressure difference will be more enough to capable of holding this whole plane to uplift it. So we can calculate amount of upliftment or pressure difference related to Bernoulli's principle. So let's say this is first portion and this is second portion. So according to Bernoulli's principle, P1 plus half rho V1 square plus rho GH1 equals to P2 plus half rho V2 square plus rho GH2. Since this plane or H1 and H2 is quite comparable to each other, so they will just cancel out. Just move this P2 to left side and rest of the term to right side. So you'll get P1 minus P2 as pressure difference between bottom and upper part must equals to half rho V2 square minus V1 square. Or you may reverse it since pressure at bottom is greater as compared to pressure at top. So we may write it as P2 minus P1 equals to half rho 2 V1 square minus V2 square. Is it clear till this part?
Yes, sir.
So why are we neglecting those rho GH?
Since we are just considering that there is no any much difference in level of height for these two different ends. They are quite comparable. Now, this pressure difference between these two ends will be capable of uplifting the entire mass of plane or passenger. So pressure equals to force by area of cross section, and force will be due to mass of entire system. So it will be mg divided by area of cross section. equals to half rho. This is b square minus v square. We can write this particular term in terms of a plus b times a minus b. So it will be v1 plus v2 times v1 minus v2. We may rearrange this equation as v1 plus v2 divided by 2 and v1 minus v2. This particular term, v1 plus v2 divided by 2, called as average velocity, and this v1 minus v2 treated as difference in velocity between two different layers. So we can write density of air times average velocity times difference in velocity between two different surfaces equals to mg divided by area of cross section. So you'll have to calculate amount of difference in velocity between bottom and top surfaces. So we can write delta v equals to mg divided by rho a v average. So this will be our final expression for difference of velocity between two surfaces. Is it clear? Nabila, any doubt?
No doubt, sir.
Okay, just write it down.
Sir, how P1 minus P2 became P2 minus P1?
I've just reversed the entire part. Move this P2, P2 to this point and P1 to this point. Or you will say take negative sign common from this part as well as this part. Since P2 is greater as compared to P1, that's why I've written like this.
Then
You all have written?
Yes.
a plane moving at 900 km/h carrying total mass of 2 into 10 to the power 3 kg. Find difference in velocity between lower and upper surface to uplift it if area of wingspan is 25 meters square. Density of air is 1.3 kg per meter cube, and take gravity to be 10 meter per second square. Just put all the values in the above formula and try to simplify it.
So you have to convert hour to seconds.
You have to convert all quantity in terms of SI unit. We have 900 km per hour, that is speed. So just multiply it by 5 by 18 to convert it into meter per second. Raza, you got any answer?
No, sir, I'm doing.
Okay. We have velocity as 900 km per hour. So just multiply it by 5 by 18. So 18 into 5, it will be 90. So it will be 250 meter per second. Mass of entire system is 2 into 10 to the power 3 kg. And density is 1.3 kg per meter cube. So according to the above relation, velocity or difference in velocity will be mass times gravity divided by rho A times V average. Area of entire wing of plane is 25 meters squared. So just put all these values in this equation and simplify it. Let me solve. Mass is 2 into 10 to the power 3. Gravity is 10. Divide by density 1.3. Area of wing is 25 and velocity is 250. So this 0 and this 0 will cancel out. So you can expand this 2 into 1000 divide by 1.3 into 25 into 25. So 25 in 4 times will be 100. Similarly, 5 in 8 times and 5 in 5 times. So it will be 8 into 2, 16, divide by 5 into 1.3. 16 by 5, it will be 3.2, divide by 1.3. So 13 into 2, 26, 60, 13 4s, 52, approx 2.5 meter per second. Is it clear?
Yes.
Yes, sir.
Gautam,
Yes, sir. Got it.
Minashi, any doubt?
No, sir.
You all have written?
Yes, sir, done.
Just one. Okay. You all have written?
Yes, sir, done.
Okay. Next is application of Bernoulli's principle, Torres-Lee law. Suppose you have a tank in which liquid is filled and there is a hole at some depth. Suppose liquid in this particular tank is up to this point. And through this hole, they may come out like this to fall at this point. So we have to calculate velocity of ejection of liquid through this hole. That is called velocity of efflux. Height of this particular level of liquid from bottom point is h. Hole is met at some depth h from the surface, so that this will be h minus h. Since this top part is exposed to atmosphere, so there will be atmospheric pressure at this point, and this is also exposed to air, so atmospheric pressure will be at this point also. Now just consider this particular term in as equivalent of tube. So let's say this is one end, and this is the other end. Like this. So let's say this is first end and this is second end. So we have to somehow calculate this VE, that is velocity of efflux, and then I can define you its significance. Do you have any doubt in this particular diagram?
So P naught is atmospheric pressure, right?
Yeah.
Okay.
So at both ends, since at first end, it is directly exposed to air, so there will be atmospheric pressure. And at this second end, at the hole, it is also directly exposed to air, so there will be atmospheric pressure. So consider a tank, or say open tank, in which liquid of density rho is filled up to h. A hole is cut out at depth below the surface. Through which liquid is ejecting at velocity VE, that is velocity of efflux. So we have to calculate this VE by using Bernoulli's principle. Now, since this particular tank is very large as compared to this small hole, so there will be a very small decrease in this particular level by ejecting liquid through this small hole. So we can say velocity of falling in level of liquid at this first end will be approx 0. Is it clear?
So what's
Button?
so could you repeat?
Since this particular tank is very large, or you can say area of this particular open end is very large as compared to this small hole. So on ejecting liquid, there will be very small change in this level of liquid at this end. So we can
Okay, sir.
consider velocity V1 at this first end will be very small as it tends to 0. Okay.
Yes, sir.
Now, according to Bernoulli's principle, P1 plus half V1 square rho G H1 equals to P2 plus half rho V2 square and rho G H2. P1 is P naught, that is atmospheric pressure. V1 is tends to 0, so it will be 0. Rho G H1 is actual height of this particular level of liquid. P2 is P naught. Half rho V2 is velocity of efflux. Rho G H2 is H minus H. Sham, any doubt?
Yes.
Okay. So this P naught and this P naught will cancel out. Now move this term to left side. So you will get rho GH minus rho GH plus rho G small h equals to half rho V squared. So this term and this term will cancel out. Rho and rho will cancel out. So you get velocity of efflux equals to root under 2gh. Nabila, any doubt?
No doubt, sir.
Okay. Just write it down to this part. You all have written?
Yes, sir, done.
Minashi, done?
Yes, sir.
Okay. Now suppose there is a particle whose initial velocity is 0, since it is dropped, and we have to calculate velocity attained by it on covering height h. So according to third equation of motion, v square equals to u square plus 2gh. U is 0, so just neglect it. So you'll get v equals to root under 2gh. Is it clear till this point?
Yes, sir.
Now just compare these two different velocity. Are they same or different? Just
Repeat
compare.
the right part. The right part.
I've just considered a body which is dropped in free fall,
Yes.
or say free falling body. So initial velocity of it would be 0. On covering h meter height or h unit height, it may acquire v equals to root under 2gh. Now this velocity and this velocity is equal to each other. So we can relate these two terms and say liquid on falling through height h behaves as particle in free falling. Is it clear?
Yes, sir.
So we can write at this point, hence it behaves as free falling body under gravity. Mazia, any doubt?
No, sir.
Okay.
Sir,
Yes.
what if we are sitting on a cylinder which is falling, which is free falling, and then the liquid is also falling out of the cylinder? Will it
No, no.
appear motionless to us?
This particular relation is basically defined as if liquid is falling freely under the effect of gravity. So velocity of ejecting liquid will be this much, which is as equivalent as a body, which is freely falling through height h. So these two get same amount of velocity, or they two will acquire same amount of velocity. Now, if this entire system falls freely under the effect of gravity, in that case, net acceleration of this entire system will be 0. So there will be no ejection of liquid. Okay.
Net acceleration will be equal to g, right?
Just 1 minute. In this part, I'm not following this entire system. We are just considering the falling of liquid part only, not the whole tank part.
Yeah.
Okay. Suppose if you consider if tank is falling freely under gravity, in that case, net acceleration of body will be 0. So velocity of efflux will become 0. So there will be no ejection of liquid. Is it clear?
So, but why is net acceleration 0?
Suppose this is your system and there is a body inside it. So if you're going downward by some acceleration A, according to the concept of pseudo force, do you know the concept of pseudo force?
Yeah, sort of attacks upwards.
If a system accelerates downward, there will be some force developed into this particular body, which will tend to move this opposite to it. So there will be a force opposite it. So it will be accelerated towards upward direction by m times a. Since it is acted upon by downward direction, mg, so the net force acting on this body will be m times g minus a. In this case, it will be termed as normal reaction or weight of the body in this particular condition. Now suppose a equals to g. So this will be replaced by g. So this entire system will become 0. It means net acceleration on this body, which is enclosed in a system which is freely falling, will be 0. Is it clear?
Yes, sir.
That's why this entire system, if falls freely, net acceleration will become 0. So there will be no ejection of liquid. It means velocity of efflux will be 0.
Okay, sir. So this will keep the liquid in.
Yeah. Raza, any doubt? You all have written?
Yes, sir.
Now, just see the geometry of this particular ejection liquid. It is behaving just like projectile or horizontal projectile, isn't it? So we can calculate its time period, its horizontal range, and on the basis of which we may define some other term as well. So next is time of fall. According to second equation in vertical direction, S is equals to ut plus half times at squared. Vertical displacement of water is or liquid is h minus h. There is no initial vertical component of velocity, so it will be 0. Vertical acceleration due to gravity times t squared. So on simplifying it, you will get t equals to 2 times h minus h divided by gravity root under. So this will be your time taken by liquid to hit ground. With Sham, is it clear?
Yes.
Next is horizontal distance covered by this liquid to hit the ground, which is also called as range. According to second equation along x-axis, S is equals to ut plus half times at squared. Horizontal distance is range. Initial velocity along horizontal direction is ve. Time taken is t, and there is no acceleration along horizontal direction, so it will be 0. Now, if you put the value of efflux, what we have calculated above, so it will be root under 2gh, and time of flight root under 2 h minus h divided by gravity. So this g and this g will cancel out. So 2 and 2 will become 4. So you'll get 2 root under h times h minus h. So this will be horizontal range covered by this stream of liquid. Is it clear? Gautam?
Sir, acceleration is 0, right? But it is same as g, right? The acceleration.
We are just considering, suppose this is
Okay, in the horizontal direction, there's no g. That's why, right?
yeah.
Okay, good.
Suppose this is your hole and through which liquid is coming out horizontally. So initially there is only horizontal component of velocity only. So it may fall like this due to the effect of gravity. So we are just considering at the horizontal point. So it will be only VE along horizontal direction. There is no component of velocity in vertical direction. And gravity will act in vertical direction. There is no any acceleration in horizontal direction. So Uy will be 0 and Ax will be 0. Okay.
sir.
Now, next thing is you'll have to define what will be the condition for getting maximum range of this particular stream. So how to define maximum or minimum of a particular function? Raza, do you have any idea how to define maximum or minimum of a particular function? Mazia? Yes, Raza? Okay. I defined you a topic in mathematical physics before chapter number 3, in which I defined you 5 different applications of calculus, in which the last application was if you have to calculate maximum or minimum of a particular function, just differentiate that particular function and put it to 0. So condition of getting maximum or minimum of a particular function is differentiate it and put it to 0. Similarly, in this part, if you have to define maximum range, as this range is depending upon a small h, as a small h is variable, capital H is constant. So just differentiate this part and put it to 0. So for maximum range, differentiate it and put it to 0. If you differentiate it and put it to 0, you will get h equals to h by 2. It means if a hole is cut at the midpoint of this entire tank, it will give you maximum horizontal range of stream. And range in this case will be equals to h. Is it clear?
So could you repeat it? Because I wasn't there when you explained the calculus part.
Okay. Whenever you have to calculate maximum or minimum of a particular function, just differentiate that particular function on whatever it is depending upon. In this part, it is depending upon the small h, as small h is variable in this case. So just differentiate this r with respect to small h and put it to 0. Let me prove it. We can write r equals to 2 times root under is h into h minus h square times whole to the power 1 by 2. We can write it like this. Now in this part, we have 2 different functions. One is exponential and one is the base part. So the outermost function is the exponential part. So just differentiate the outermost part first. So dr over dh will be 2 as coefficient. Keep it outside. N x to the power n minus 1. This is the first part of differentiation for this exponential part. Next is to differentiate it base. H is constant, small h having power 1. So on differentiating, it will be just 1. H square on differentiating, it will be 2h. Put it to 0. This entire part will move to denominator and it have negative exponential. So on moving to the right hand side, on multiplying or dividing with 0, this entire term will become 0. So you're left with h minus 2h equals to 0. So h will be h by 2. Is it clear?
Sir, how did you get h into 1?
whenever you have x to the power n and you have to differentiate it, the rule
Okay.
of differentiation is n times x to the power n minus 1. So in this part, h is constant, so keep it outside as a coefficient. This small h is variable which having exponential 1. So we can write 1 h to the power 1 minus 1, which will be 1 h to the power 0, which will be just 1.
Got it, sir.
Okay. Similarly, in second part, when we have h square, we can write 2h to the power 2 minus 1. So it will be just 2h. Is it clear?
Yes, sir.
So you don't have to revise this entire part. You have to define only, or you have to keep in mind only in this part only. If a hole is cut at the midpoint of tank, it will give you maximum range. That's it. Okay.
So during this differentiation, you multiply it, right? Or it's equal to between the.
At this point, multiplication.
Okay.
Just 1 minute, I'm defining you what I have done here. We have two different terms. One is exponential that I have written for this root part. And I have expanded this particular base as this. So we can treat this particular term as two different function or composition of two different function. One is exponential function and one is algebraic function. So whenever you have two different function and combine or combination of two different function or three different function, first make them or first order them from outside to inside. So we have outermost function as this exponential part. So just differentiate this exponential first, keep the rest of the term as it is. Then next to the innermost part, we have algebraic function. So I've differentiated it later. And there will be multiplication in between them. This is called chain rule. Okay.
Yes.
Do you have any doubt to this part? Raza, is it clear?
Yes, sir. Clear.
Okay, just write it down. Minashi, any doubt?
Yes, sir.
You all have written?
Yes, sir.
Mazia?
Yes, sir.
Okay. So this is all about the entire part of this fluid. So we have just completed. Do you have any doubt from this entire chapter? Okay, no doubt. So next move on to the next chapter, that is thermal properties of matter. First thing is, what do you mean by temperature?
So in the previous chapter, the Reynolds number, right? There you explained the rate of flow of liquid. Q equals volume of liquid flowing by tube. That part actually I
Yeah.
didn't understand. Can you repeat it again? Just that part.
I define Q as rate of flow of liquid. Rate of flow of liquid means volume of liquid flowing per unit time. So let's say volume divided by time. We can write volume in terms of area times length divided by time. This length per unit time is also called velocity. So it will be termed as A times V. So this will be equal to Q. So Q is simply a physical quantity to define this entire motion of liquid. Is it clear?
Yes, sir. Sir,
And
you
this
have,
may signifies, yes,
you had given some pi d square v by 4.
just 1 minute. Okay, this part.
Yes, sir.
I've taken Q equals to area times V. Area is area of that cross-sectional area of that tube, which will be pi r square. But in terms of diameter, we can write pi d square by 4. So from here, we have derived V in terms of Q. So it will be V equals to 4 times Q divided by pi d square. And just replace this particular value of V in this Reynolds number by this much amount. So you'll get this relation. Is it clear?
Yes, sir.
Any more doubt?
No, sir, clear. Sir.
Okay. So what do you mean by temperature, Gautam?
So
Any
the
idea?
measure of average kinetic energy of the particles in a system.
Kinetic energy of particle in a system. Okay. This is mainly a microscopic concept of temperature, you can say, which I will learn in chapter number kinetic theory of gas. But in macroscopic level, how can you define temperature?
The degree of hotness or coldness of an object.
Good. Suppose if there is a body and if you touch it like this, in summer, you feel nothing by touching it, but in winter, you feel some coldness by touching this particular body. It means temperature is just a relative term with respect to some other body. If there is difference between temperature or there is some difference in hotness or coldness related to some given fixed value or given body, then we can call it as hotness or coldness relative to some specific fixed value, or we can say the measure of degree of hotness or coldness of a body is called temperature. In some other way, we can say temperature is a physical quantity which defines the flow of heat from one body to other body till they acquire equal temperature. Is it clear?
Yes.
So temperature is basically the measure of degree of hotness or coldness of a body. It is relative term which is defined with some other reference as well. Now its SI unit will be, SI unit is Kelvin, and it is measured by an instrument which is called thermometer, measured by thermometer. Now, there will be two different types of thermometer depending upon its range. One is clinical, ranging from 36 degrees Celsius to 42 degrees Celsius, or you can say human body temperature. Next is called laboratory thermometer, ranging from melting point of ice to boiling point of water. Melting point of ice is also called ice point, and boiling point of water is also called steam point. Now, on the basis of this particular range, we can define formula to convert one unit in some other unit, or how to define a particular scale. So T minus LFP divided by UFP minus LFP will be constant for all different scale of measuring temperature. T is temperature on that scale. LFP is lower fixed point, or it is also called ice point or melting point of ice. UFP is upper fixed point. It is also called steam point. Is it clear till this point?
Yes, sir.
So we can write a different scale related to this formula as T minus LFP divided by UFP minus LFP equals to, let's say in terms of Kelvin. So it will be K minus melting point of ice in Kelvin scale will be 273. Boiling point of water will be 373 minus 273. In terms of Fahrenheit, it will be F minus 32 divided by 212 minus 32. In terms of Celsius, it will be C minus 0 divided by 100 minus 0, and so on in any other scale as well. Is it clear?
Yes.
Reza, any doubt?
No, sir.
Okay, just write it down. I'm giving you just 2-minute break. Okay, then I will resume. Okay. So you all have written till this part. Gautam, any doubt?
No, sir.
We can write this particular relations some other way also. Suppose if you have to find temperature dependency resistance, so we can write resistance at some temperature C minus resistance at 0, resistance at 100 minus resistance at 0. We may find length in terms of temperature, density in terms of temperature by formulating like this way. Now, first question related to this is find temperature at which Kelvin equals to Fahrenheit numerically. Fahrenheit equals to Celsius numerically. Try to find. Just put the value of K and F as X and X in equation this and equate them. Similarly, F and C. It means put the value of K to be X in place of K. and F as well. And simplify it. Similarly, in second part, or take Y and simplify it. Try to solve. Gautam, you got any answer?
No, sir. Wait, I'm doing.
Minashi,
No, sir, doing.
Let me solve. We can write this particular term as x minus 273 divided by 373 minus 273 as 100 equals to x minus 32 divided by 180. So this 0 and this 0 will cancel out. So just cross multiply it. So it will be 18x minus 18 into 273 equals to 10x minus 320. So move this 10x to left side. So 18x minus 10x will be 8x equals to 18 into 3, 54, 18 into 7, 126 plus 5. It will be 131. 18 into 2, 36 plus 13. It will be 49 minus 320. So it will be 4, 9, 5, 4. So x equals to 4594 divided by 8, 5, 40, 5, 9, 7, 56, 3, 4, 32 to 5. So at this numerical value, Kelvin and Fahrenheit coincides over each other. Is it clear? Gautam?
Yes, sir. Yes, sir.
Mazia, any doubt?
No, sir.
Similarly, we can find y in the second expression as well. Y minus 32 divided by 180 equals to y over 100. So this 0 and this 0 will cancel out. Just cross multiply it. 10y minus 320 equals to 18y. So minus of 32 equals to 8y, or y equals to minus of 40. So just remember these two different values on which Kelvin and Fahrenheit coincide and Fahrenheit Celsius coincides. Minashi, any doubt?
No, sir.
Okay. You all have written?
Yes, sir.
Let me ask you a question. A faulty thermometer reads ice point as 5 degrees Celsius and steam point as 95 degrees Celsius. Find reading of 60 degrees Celsius on this scale. Just use the same concept. T minus LFP divided by UFP minus LFP will be always constant for all different types of thermometer, whether it is correct thermometer or faulty thermometer, whether it is based on resistance measuring, length measuring, density measuring, and so on. In this part, there is a relation between faulty thermometer and degree Celsius. So we can write, there is a faulty thermometer. So in terms of faulty thermometer, just take F. Ice point is 5, upper fixed point is 95, and lower fixed point is 5. In terms of Celsius, C minus 0, 100 minus 0. C is given as 60 degrees Celsius. So we have to find the value of F. Just equate these two terms, put the value of C to be 60 degree and find F. Try to solve. Raza, we have -5 here. So on moving to right side, it will become +5. Good, Atisham. Good, Raza. Gautam, just check your calculation. Good, Minashi. F minus 5 divided by 95 minus 5, it will be 90 equals to C 60 divided by 100. So move this 90 to the right side. So it will become F minus 5 equals to 60 into 90 divided by 100. So these two zero will cancel out this and this. So 9 into 6, it will be 54. This minus 5 will move to right side. So 54 plus 5, it will be 59. Gautam, is it clear?
Yes, sir.
Okay. Do you have any doubt till this part to any one of you?
No, sir. Yes.
Nabila?
No doubt, sir.
Okay.